Okay, so for this one here, the extra sheet is just the extra sheets at the back of the package where I said do the extra questions because there's more practice, because usually students are like, can I do a few more practice questions? There's a lot in this section already for practice, plus I gave you extra practice questions that I've made up over the years. Okay, so there's extra at the back of the package. We're always looking for vertical asymptote, which we know is the denominator equals 0. The horizontal, we are looking at the leading coefficients. We're looking at the degree to the degree. Right, so horizontal asymptote is the degree to the degree. We went through that in the other lesson, so I'm not going to go through that again. We went through that in 5.2, where it's the looking at the degrees of the numerator and denominator for horizontal. I didn't mention oblique. No, see, I'm missing oblique. So oblique should be on here. Oh, here, oblique for holes. Oh, I should have done this. So oblique asymptote, I should put that in there. So you're looking for vertical, horizontal, and oblique asymptotes. You sketch it. When we sketch it, we usually want domain, the intercepts, equations of asymptotes, and I reminded you that as well. So you're doing equation of asymptote on the sketch, and we're going to do positive, negative intervals, all that stuff. We have all this. Make sure you look for holes, and then the rest is the new function, which means you cross it off and you have the new function. So again, we just reviewed that in 5.2, so we're good for that. My new thing, so the new thing that we're adding to 5.3 is we're going to put it all together and we're going to sketch it. Also, I'm going to add this. Okay? We're going to state the approach. So the approach that we're going to state is when we're approaching for two approaches for each asymptote. So whenever I have an asymptote, I'm going to say what's happening around the asymptote. This is new, and the checking I'll show you. If we ask you to check it, then you're going to check it. If we don't ask you to check it, you don't have to, but sometimes we will ask you to check it, and I'll show you what that means as we go through the questions. Okay? So this is new, the approach part. Everything else is pretty much the same. So let's do the rest of the stuff that we do know, and then we'll add the new approach stuff to it. So for example 1, I want you to state holes, asymptotes, all of them. So that should be vertical, horizontal, and oblique, and domain, the intercepts, all that stuff. And we're going to talk about positive, negative intervals, which I think we did, was that way back in chapter 1, where it's above the x-axis negative, and we're going to sketch the graph, right? So we're going to put that together. So first thing here, A. Start your question, especially when you get a bigger question with all this stuff, on the left side of your space, right? So on tests and stuff, try not to start in the middle of the space, try to start on the left, that way you can keep going to the right. Some people go, oh no, I went left and right and I lost where I was. So for those of you who are having trouble organizing, I always start in the left and then head to the right, and then I get more space. Sometimes that's blank, but that's okay, right? Some people start in the middle and go, oh no, now what do I do? So we're going to graph it, so leave room here. So I'm going to start this here on the left, right? Because then I have room for my graph here, and I don't have to squish it in as much. Okay, so here, A, holes. Any? No holes. All right. B, asymptotes. I'm going to look for vertical. Vertical is usually easiest, so look in the denominator. X equals -3. Good. Horizontal. We go degree 0, degree 1. So it's 0 to 1. Higher on the bottom, bigger number on the bottom. It's going to pull my asymptote, my horizontal asymptote, to 0. If there's a horizontal, there is no oblique. None. Good? All right, next one. C. Domain. Yes? Oh, yes, very good question. For on a test, you do want to write the word none. Yes. So make sure you're doing equations for all these, and make sure you write the word none. If you leave it blank, I figure you didn't know what I was asking, and you left it blank because you didn't get to it. So write the word none. Yes. Okay? If we give you blanks on the line, I just write quickly none, 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 right? And then later on when we do blanks, you can put a slash through it and say none, and that way you chose it. But if there's no slash, I would write none. Actually, honestly, I write none just in case, because I'm not sure if you started the question or not. Write the word none. Yeah. Okay? We'll give you blanks sometimes as well, and you write none. Right? Because I don't know if you just didn't get to it or if you know that there isn't one. So yes, thank you. Write the word none. Okay, for C, Domain. For the domain of this, again, we already know what the graph looks like. It's when it's a reciprocal function. The only place on the domain you're looking for is the restriction. The restriction is going to be here, right? So we know that the restriction is that x cannot equal -3, right? So in my mind, I've got that. So again, I always want interval notation unless otherwise asked. So if I want interval notation, I would say x is going to be from -infinity to -3, or, and you can use the word or the symbol, -3 to infinity. If you do set notation, you would do set notation in x is an element of real, and you would say x cannot equal -3. Okay, so I'll ask for one notation or the other. If I don't, I want interval. Okay, and usually it says on the top of the test, interval if not asked, or set if not asked. So read the instructions. Okay, so that's it. For C, how about D? Okay, D is intercepts. D is going to be x-intercept, which is when y equals 0, right? And then also y-intercept, which is when x equals 0. You don't have to write this part, but just title it with this. So if you write x-intercept, y-intercept, that's sufficient. You don't have to equal 0 part, but I would write a title, so you're telling me what you're finding. So that part, and then you're going to say x-intercept is when y equals 0, so you're going to go 0 equals 2 over x plus 3. Okay, so what happens when you solve this? This goes up to that side, then you end up with 0 equals 2. You can stop before this. As soon as you see this, you can be like, wait, I don't need the steps for this. What happens when you bring that up? I don't have an x left. None. Okay, so if you see this earlier, I don't need to see the steps. Okay, so if you're like, wait, there's none, you can go right to none. Yep.
If there's a horizontal asymptote, anyways, you won't be able to get.
No. Question is, if there's a horizontal asymptote, which we have here, right? If there's a horizontal asymptote, it means that there's no x-intercept. That's not what we said. A horizontal asymptote is the plateauing. So I could still have the fish, right, doing this, and then it plateaus. The middle of the graph doesn't mean there's no horizontal asymptote. There can be ups and downs. Things can be happening, and then it plateaus. It's even like a sound wave, right? Like it's this, and it plateaus to be something, right? So there is ups and downs. The horizontal, that's a very good question. So horizontal and oblique asymptotes, that doesn't mean, well, oblique, let's not talk about that, but horizontal asymptote means that at the very end, it's plateauing. I think of horizontal asymptote as a plateau. It's not always 0, so it could be going through here, and it could go up, through, down, back, and then plateau here. So horizontal means it's plateauing at the ends of the graph. It doesn't mean it doesn't go through. So whether it's going through 0, it can go through 0, even though, right? Even though there's a horizontal asymptote. Very good question, right? Because people get that confused. Horizontal asymptote means at the end it's plateauing to a number. It doesn't mean in the middle it can't go through. Okay? Vertical, though, means never, ever, ever can I cross a vertical. So if this is my vertical asymptote, I cannot cross it. I can't go, yeah, but my line went through. That's impossible. Because as soon as there's a restriction, you can never cross that. You can't say, but I also went through. You can't. How do you go through a vertical? It's never, never. So vertical is a never go through. A horizontal means plateaus to that in the end behavior of the graph. Right? So that's different kind of ideas of asymptote. Asymptote means approaching, but they're two different types of things. Yes, question?
So for horizontal, it's just showing like the end behavior?
Yes.
Whereas like it's not showing the beginning of the vertical.
Exactly. Horizontal asymptotes are showing end behavior. So that's end behavior of the graph, right? So vertical is saying never cross it. That's a restriction. So this vertical is my restriction. That is this domain. Vertical and restriction are connected. Horizontal is saying end behavior of the graph. Yes. Good? All right, does that make sense? And again, we will do graphs where it crosses through, where you go whoosh through the horizontal asymptote and back, because it's plateauing there, but in the middle, it did go through. Okay? But the vertical is a restriction. Vertical is a restriction. Never. That is a never scenario. So they're both asymptotes, but they're different asymptotes. Vertical and horizontal act different. Good question. And then here, y-intercept, we're going to go f at 0. So that would be 2 over 0 plus 3. You can go faster. It's just 2 over 3. So I have no x-intercept. I have a y-intercept. And I'm looking for the positive negative intervals. For the positive negative intervals, I will do that later. So I'm going to do that here on the bottom. I'm going to answer that in a minute. So I'll do positive negative in a minute. I'm going to do that from the graph. You can answer the positive, some of these things from your graph. Because if you're graphing it anyway and you're like, oh, I'm just going to see where it is, I can do it here. Please put your graph, so watch here, I need some room. Please put your graph up here, and I'm going to put some stuff down here. So don't put it in the middle, we're not done. I want to talk about this part here. I want to talk about the approach for a minute. Okay, so let's put the graph up here, okay, and then leave some room down here because I want to talk about approach. So we're going to start with my asymptote. X is -3. And my other asymptote, I always start with my asymptotes and my points. And my point is at 2/3. This point here, I'm going to do it in pencil. Remember, don't zigzag to hit it. We just want to hit it at some point. Okay, so that I know it's 2/3. There. Okay. I know this graph already, so let's just go ahead and graph it because we already know what this graph looks like. So we don't have to pretend that we don't know. It does this, so just swoosh it through like that. Remember, I don't want an extra zigzag here, so if you have to, erase the dot and just make sure it goes through smooth. Don't put an extra cubic or wiggles or anything here. Arrows on the end and then here. Right, because we know what that graph looks like. So where is it going to be positive versus negative? Positive means above the x-axis, right? And negative means below. So the positive is when x is, it's positive all the way on this side to the right of -3. Does that make sense? So x is, the y values, remember, I'm always asking you the y value. Where are the y values positive? And you answer when x is to the right of -3. So you're going to say from -3 to infinity. And then I'm going to say, where is it negative? That would be, when are the y values negative? And you're going to say when x is to the left of -3. Okay, now I want to talk about the end behavior, which is the horizontal asymptote, and the approaches of the vertical asymptote. The way I'm going to write this is I'm going to write it using limits. So this is something new, okay? This is introducing us to the idea of limits, which we don't get to until calculus, but I want you to write it this way because then I don't have to unteach you how you write it when you get to calculus. Because the problem is we used to teach it in a different way here, but then when you get to calculus, I say stop writing it that way. Stop it, stop it, stop it. So I'm just going to teach you the proper way to write it here, and then you don't have to unlearn it if you do take calculus. If you don't, you just write it this way anyway. It'll just be the one way you learn it. Okay? So I'm going to go through the limits. I'll stop here for now, and this is where we'll begin on Monday. We'll start with the limit idea. Okay? There you go, and I'll pause the video.